Thank you for that kind introduction. Today I'm going to talk about TinyML and the opportunity that it has to revolutionize all of machine learning, and not just in little microcontrollers and so on, if it sets its sights a little higher than it has in the past. To begin, when we look at machine learning today, there seems to be this conflict that's set up between the big data center in this corner, which has zillions of computers and giant warehouses to do giant computations for machine learning. And then at the other end of the spectrum, in this corner, we have tiny battery-powered devices that are sufficiently underpowered they can only run tiny networks like SqueezeNet or ShuffleNet. The perception is that if you want to do really serious inference, you'd better use the data center because there's just not enough horsepower at the edge to be able to do non-trivial inference. In the remainder of this talk, I'm going to argue that this dichotomy is false, that actually it is possible to have rainbows and unicorns where we can have the best of having models that are small and efficient while without compromising the quality of inference that we've gotten used to from the data center. So to begin, I have to acknowledge the fact that models are getting bigger every year. If you look at the chart here in the lower right, from millions to tens of millions, and these days with GPT-3, it's 175 billion parameters, and since then, there's a trillion and even 10 trillion parameters. So those are the facts. But those facts are accompanied by the myth that networks have to be enormous, that if you're going to do significant compression, that accuracy is going to go out the window. And I'm going to challenge that myth later in this talk.